Hi there, welcome to Solving Radical Equations. We're going to take a closer look at how we can actually solve equations when they begin to involve radicals. Mostly square roots is what we're going to focus on. You'll see we have a couple of key words: radicals, radicand, yes, rational exponent, and yes, extraneous solutions. We kind of saw that previously, but we're going to dive into that concept a little bit more on this kind of topic. The very first example looks pretty friendly. It's going to kick off. It's going to be exactly what we would hope it to be. If I'm trying to solve for s and I'm trying to clear a square root, I'm still going to try to undo something on both sides. So in this case, I'm going to go ahead and square both sides, which will leave me -8 minus 2s equals 0. So that already is a whole lot easier for us to solve because I can simply add 8 to both sides, again, keeping things nice and balanced, as all things should be. Even powerful Thanos didn't have too crazy ideas. These are going to cancel out. This is going to drop down. So I've got -2s is going to give me +8. And then I can go ahead and divide everything by a -2. You'll see all of my steps are very, very clear. So in this case, it looks like s is equal to -4. So in this case, yes, s will in fact equal 4 for a final answer, so I'm going to box it. All right, hopefully you saw a similar idea here, like on the last one, almost identical. Hopefully you jumped in and squared both sides. So that should have been the very first step. You can see I've kind of squared both sides and the roots canceled out. So here is already looking a little bit different. I'm seeing a squared piece. So what we're going to try to do is move everything over to one side. So you can see I've added 10 to the other side and subtracted 7p. So now it equals to 0. Now, where have I seen these before? Why, yes, factoring is going to come back. So we need to figure out first times the last, what multiplies to 10 and somehow adds to -7. Why, yes, -5 and -2 are those numbers. So again, when we factor, a quick little refresh, we always take whatever's in the middle and we break it up and using our two new numbers right here. And then we did our favorite thing when we went ahead and roped these two together, and we roped these two together and we took out common factors. So the first two, I can take a p out. The last two, I can take a -2 out, and it actually cleans up really well. And it looks like I get two possibilities because the blue piece and the purple piece both go to 0. So always be sure before you're finished, check both solutions. And why, yes, it looks like 2 works and 5 works. So I can box both of them. Here's something really nice about factoring. We're going to start doing it a bit more, so it's nice to know a couple of shortcuts that we can use in our back pocket. You'll see right here in step 2, we were trying to find something that added to -7, and we picked -5 and -2. Oh, look at that. -5 and -2. They match. This is a great, great shortcut, especially when p squared or when x squared, whenever that first term is basically like a 1. It's not 2p squared or 5p squared. It's just p squared. So it's a really great shortcut, and we'll kind of use this throughout this lesson. Okay, something that looks like this. It's a little different. It still looks like I have a square root. So we can do the same exact idea here and square both sides. So that's not going to be any different. Oh, I'm going to write this piece twice so I don't get distribution happy. The other side, I'm going to go ahead and either FOIL, double distribute, basically multiply everything out. Ooh, it looks like everything is kind of jumbled up on different sides. So let's go ahead and move both of these over to the other side. So that's going to go over here and that's going to go here. So I have regular x squared. I have 3 plus 3 is 6. 6 minus 2 is positive 4x. And then I have positive 9 minus 14. So it looks like I have a negative 5. Okay, it's going to be just like what we did. First times the last. So what would multiply to negative 5 and somehow add to positive 4. So I've still got the 0. And when I replace the middle and factor, I'll end up getting two pieces that look like x plus 5 and x minus 1. Just be sure we keep solving, so each of these pieces is going to go to 0. So it kind of looks like I have two possibilities. So I'm going to write them over here. I see x could be negative 5, and I see x could be 1. Well, if I try to continue simplifying, I'm going to get the square root of 4 is equal to negative 2. I don't think so. Let's see what happens here. All right, I've got square root of 16 is equal to positive 4. Well, now that I know is a true statement. So here it looks like this solution worked. So what are we going to call the solutions that basically appear extra? So these are what we call extraneous solutions, and they are solutions basically to a simplified version of an equation. And the problem is it will not satisfy the original equation. Okay, this one, you can see I've got a few more steps lined out because it does look almost the same as the last one, except I've got some extra stuff. In particular, I have this 5 on this side, and it looks like I have a fractional exponent. Now things are starting to get topsy-turvy. So we're going to make it look like the last one did. And we're going to go ahead and move some stuff over. So it's going to look something kind of like that. I'm going to subtract the 5, and then I can square both sides, just like I did on that last equation. And then here, you're going to see I've expanded. I've written the left side twice because I see this is squared. So I'm going to write it twice. And you can see that these canceled out. So it's almost like that square root canceled everything out. Here, you can see I went ahead and double distributed or foiled. I know some of you really like to say foil. So first, this side is kind of what I like to do. So there's my green step. Okay, I'm going to go ahead and subtract and bring everything over. And now I'm left with something that kind of looks like this. And it looks like I need to get to positive 36, negative 13. And yes, I have two possibilities. And there we are. I've got x could be 9, x could be 4. But again, did you check your solutions? And unfortunately, only one of them worked again. This one just happened to be x was equal to 9. X equals to 4. I'm pretty sure that 5 plus 1 not equal to 4. So this one, you're just going to box one of them. If you want, you can always leave both of them. Go ahead and show that you do have two different solutions. You can always label them if you would like. So you can say, I've got x equals 9, x equals 4 happens to be extraneous. So something that you probably want to ask yourself when you see these kinds of questions is the root by itself. So on this one, we had that extra 5 and we moved it over. So that's a good kind of rule of thumb, is ask yourself if the root is all by itself. And once it is, then we can try to square both sides. All right, on this one, you kind of see the same thing is happening here. This 1/2, that's kind of like our square root. Because remember, all of these fractional exponents are really the same thing as radicals. So if you don't like seeing to the 1/2, you can always change that around if you'd like. So x to the 1/2, if you want to change that, to be a square root of x, that might help you see how to square things on both sides. So here you can see I added n to both sides. I got that root all by itself. Step 2, I'm going to go ahead and square both sides. I'm trying to get rid of the square root. And I'm going to need to expand this side again. You're going to get really good at foiling because here I'm going to double distribute. And then my steps in green, I kind of simplified everything together. And then I moved everything to one side in hopes of getting it equal to 0. Okay, now I'm going to have to factor. What multiplies to negative 28 adds to negative 3. Oh, yes, there were combinations. Negative 7, positive 4. Again, it's just n squared, so it works out really nicely. So I've got two possibilities. Always check your work because, again, only one of them is actually going to work, and it was n was equal to 7. The other would be extraneous. It is extra. All right, now this one, woo, we have 2 roots and a number. Oh my, that is nothing like we've seen. All right, step 1. Let's go ahead and separate the roots, kind of like the other problems. Okay, I've got separate roots on both sides. So this is where it's gonna get kooky. You're still gonna square both sides. Here's the thing, when this part squares, we're pretty lucky because they're gonna cancel out. So I'm just gonna have a 4y plus 1. That is the good news. Here's the bad news. Again, when we're squaring, it's like we're multiplying it by itself. So I'm going to write this side twice because I'm multiplying it by itself. I'm squaring that side. So I'm going to take the first. So I see, here's the good news. Square roots cancel each other out because think of it like this. Square root of x times the square root of x is the same thing as this. So the roots cancel out. So that first piece in green is just going to be y minus 2. All right, I'm going to do this piece. I'm going to put these in some different colors here. So I've got 3 times this square root. Well, that's a little goofy. Those don't really match, so we're going to keep them separate. And it looks like I'm going to have another one of those pieces down here. So I've got 3 times another. I've got y minus 2. And then the last one is good news because it's just positive 3 times positive 3, which gives me 9. I'm going to see 4y plus 1 equals, I've got y, and I see a negative 2 plus 9. And that's going to be positive 7. So really, it looks like I have 6 of those pieces. 6 of those pieces. That's just nuts. Still looks a little weird. So here's where we're going to ask ourselves, is the root isolated? Well, it's not. So let's move some stuff over. So now I'm going to have this step in purple. Interesting. Okay, now it almost looks like that last one did, where we just had one root. So guess what? You are going to square both sides again. You get to do it twice. I would write that so you can kind of see I'm repeating my colors because I kind of am repeating these steps again. So I'm going to write that side twice. I told you, you're going to get real good at foiling. And then distribute the square. So here's 36 y minus 2. You can see I went ahead and expanded both sides. Now it's going to match what we did before. Bring everything to the same sides. And then you're going to see we're going to have a 9. Oof, these are looking a bit out of hand. 72y, and it looks like I have 108 going to 0, but let's divide everything by 9. Okay, so now I'm left with something that looks a little bit like this. Y negative 2 and negative 6 are going to come to the rescue. So go ahead, set them both equal to 0. So when I add 2, I'm going to get one possibility. And when I add 6, I'm going to get a 6 on the other side. Go ahead, check both solutions. Here you can see I have checked both solutions and they both are solutions. That's kind of interesting. So this one actually has no extraneous solutions. So you get to go ahead and box both of them. All right, we're going to end on something a little bit nicer. Hopefully you went ahead and subtracted 7 from both sides. And then we went ahead and square both sides because we're trying to get rid of the root, which turns it to positive 9. I can go ahead and add 2 to both sides. And oh, isn't that nice? We're ending on something so friendly. X looks like it could be 11. And I'm just going to go ahead and box it. I got one answer. I'm sure that's the right answer. I'm positive. Miss Hawkins is 100% sure. So here below, I've provided a graph to try to do a little comparing. So think about what we solved up here algebraically. We were trying to find where these two were equal to one another. It's kind of like y1 and y2. Interesting. Well, I can see I've got f of x is going at y is equal to 4. Well, that's all the way down here. And here's my square root function. Well, peculiar. It doesn't look like they are ever intersecting. They're completely separate from one another. So what does that mean about all of this work that we actually just did, that x equals 11? Well, that would mean it's extraneous because that function, our g of x, our square root, was never equal to 4. Those never intersected. So this one just happens to be a no solution case. So we've seen it where we get 2 solutions, we get 1, and now we've seen it where there is none.